The product rule. We're going to determine the derivative of one function times another. So f of x times g of x. We're going to start with the definition. The derivative is the limit as h approaches 0, f of x plus h minus f of x all over h. F of x in this case is f of x times g of x. What would f of x plus h be? F of x plus h, g of x plus h. So when we put those in, we get f of x plus h, g of x plus h, minus f of x, g of x all over h. Now, there's nothing we can really do with this. There's no common terms anywhere. We can't factor, we can't group. So what we're going to do is add something in. We're going to add a term in that has something in common with this expression and something in common with this expression. What could you add in? What we're going to add in is f of x plus h, g of x. And if we are adding it in, we're going to immediately take it away again. So first, where did this come from? We needed something from here. So we took the f of x plus h. So it had something in common with the first expression. And then it needed something in common from here. So we took the g of x. Could we have done g of x plus h, f of x? Absolutely. So we've added this new term in. Now in math, you can't just simply throw new terms in. So if we immediately subtract it away again, we haven't changed anything. And you might be asking, what is the point? The point is that we can now put some terms together. So the first thing we're going to do is just swap the order of these two. We're going to put the negative one over here and the positive one over there. And then we'll separate them into two fractions so that we can get a better idea of what we're doing. So all we did is we took this first one and put it here, and the second one and put it there. They were both over h, so they're still over h, and they both had the limit as h approaches 0. Okay, so this is the line we just ended up with. What you're going to look for now, can you find anything common here? Is there anything common to this term and this one? I'm hoping you notice that f of x plus h is common. And what's common over here? G of x. And that was planned. Remember we said the term we were going to add in had to have something in common with the first term and something in common with the last one. So that's why we put in f of x plus h, g of x, just so this would happen. All right, let's factor. The common term of f of x plus h will come out front. What's left? G of x plus h minus g of x all over h. This one, the common term is g of x. What's left? F of x plus h minus f of x all over h. Now, some of you might be a little bit upset with me. The f of x plus h used to be over h, and now it's not. So when we write down 2 over 3, that's the same as 2 times 1/3. So it's okay to pull the term out front. It is the same expression. Okay, what does this do for us? We're now going to calculate the limit. The limit as h approaches 0. If this becomes 0, that'll just be f of x. The big question to be answered today is, what is this? We have the limit as h approaches 0, g of x plus h minus g of x all over h. I'm hoping you look at that and say, wait a minute, isn't that the derivative? So that is the derivative of the function g. So that will become g prime. Over here, h is going to 0. There is no h, so that just becomes g of x. And what does this become? We have the limit as h approaches 0, f of x plus h minus f of x all over h. Please tell me you instantly recognize that as the derivative. So what are we left with? F of x, g prime, g, f prime. Now, some people like to memorize the rule this way. I prefer to swap these two. So I'm just going to change the order to, swap them and put it out over here. So I'm going to take this term, swap the terms and put it over here. And then take this term and put it over there. Why do I prefer this way of memorizing the function? Here's why. If you have one function times another, your derivative is the derivative of the first times the second plus the first times the derivative of the second. I like to think of it as the derivative just moving along the functions. So the derivative of the first one, everyone else, derivative of the second one, everyone else. Because then, if we're faced with this situation, f times g times h, can you guess what the derivative might look like? Derivative of f times everybody else, derivative of g times everything else, derivative of h times everything else. And that's why I like to remember the rule this way. So, what is important for today? Showing you the derivation. It's good for you to see where rules come from, so they're not just things that are memorized out of the blue, but you don't have to show me this at any point again. So I'm not expecting you to regurgitate the rule. I'm just hoping that you understand where it came from. So it's okay if you look at it and go, some of this was a little bit shaky. This is what matters today. If you have a function times another function, take the derivative of the first times the second, add the first times the derivative of the second. So let's put that to use. Here are two examples. This is our first function. So this would be our f function. This is our second one. This is g. We said the derivative was the derivative of f times g plus f g prime. So what is the derivative of this function? 7x to the 6, 6x to the 5, 5x to the 4, 4x cubed, 0, times the second function. So that's where all this came from, plus the first function times the derivative of the second function. So let's just make sure we understand where everything came from. This is our first function. This is the derivative of the first function, and this is the first function. So derivative of first function, first function. What's all the rest of it? This is our second function. So this is g and g prime. So there's the second function and its derivative. Am I expecting you to multiply that out? And the answer is no. So what's lovely about the product rule? If we didn't know the product rule, we would have had to multiply all this out, get all kinds of terms, take the derivative separately. With this one, you take the derivative, and imagine that you were doing this for x equals some number. You could then plug in the number and get your answer fairly quickly. Okay, try the next one. We have two functions again, the first function and the second function. The derivative, take the derivative of the first times the second plus the first times the derivative of the second. So derivative of first function, 6x to the 5 plus 6 plus 0 times the second function, x to the 4 plus x squared minus 1. And then we add the first function, so there's our first function again, times the derivative of the second. So again, to see where is everything coming from. First function. Derivative of first function, first function. So there's the derivative, and there's the first function. Okay, what's the rest of it then? G of x is the second function that appears here, and then its derivative. So g of x unchanged, and then the derivative. So that's it. It's a fairly quick rule. Get comfortable with it, because we just keep developing new rules. And I've found in the past some people think, what does it matter if I know my rules? And then they eventually learn them. But in the meantime, they've really struggled with the course. So please do yourself a favor, get all the homework done, get comfortable with this rule, memorize it, get it in your head. It'll make your life easier. All right, get yourself to work.